So we want to write the explicit and recursive rule for this function now. So first thing we have to do is find the common ratio. So we're going to go ahead and pick some whole numbers just because we can. So let's look at the values when our inputs are 4 and 3. When our input is 4, our output is 1. When our input is 3, our output, 5 over 1, these values here. 5 over 1 is equal to 5, so that's our R. And then our initial value, f of 1 is equal to 1 over 25, so that's our value of A. So our explicit rule, f of n is equal to A, which is 1 over 25, times our common ratio, 5 to the n minus 1. Since we're starting at position 1, we have to pick n minus 1 for our explicit. Our recursive rule, so f of n is equal to our common ratio, 5 times f of n minus 1 for n is greater than or equal to 2, and f of 1, our original position, is at 1 over 25. So again, rewriting it, f of n is equal to 1 over 25 times 5 to the n minus 1 for the explicit. Recursive rule, 5 times f of n minus 1 for n greater than or equal to 2, and f of 1 is 1 over 25. If you were told that a geometric sequence had an initial value f of 5 is equal to 5, could you write an explicit and a recursive rule for the function? You could. You'd still just be missing some information. You don't know the common ratio value. You only know the initial value. So it would just have to be something like f of n is equal to our original value, which is 5, times r to the n minus 1. All right, so first thing we want to do, we want to find out what's the common ratio. Again, it's easiest to kind of pick some whole values here. So we'd want to take f of 4 over f of 3, which is 3 over 1. So that means our common ratio is 3. Our initial point, f of 0, is equal to 1 over 27. So our explicit rule, f of n is equal to our initial value, 1 over 27, times the ratio, 3 to the n. We keep it at n since our original position is 0. Recursive function, f of n is equal to the ratio 3 times f of n minus 1, where n is greater than or equal to 1. And then our initial point, f of 0, is equal to 1 over 27. So finding our common ratio, we can take f of 5 over f of 4, which is equal to 10 over 1. So that means our r value is 10. And then our original point is that f of 1 is equal to 0.001. So our explicit function, f of n, is equal to our original value, 0.001, times our ratio to the n minus 1, since we're starting at position 1. Recursively, f of n is equal to the ratio 10 times f of n minus 1, or n is greater than or equal to 2, and f of 1 is equal to 0.001. We can also graph these geometric sequences. So again, they'll give you the function. All you have to do is plug in some values and graph and see what you get. So here we've got the recursive rule, f of n is equal to 0.5 times f of n minus 1 for n is greater than or equal to 1, and f of 0 equals 16. So what they're telling us here is that our original point is 16. So at f of 1, we take 0.5 times the previous answer. So 0.5 times 16, so f of 1 would be 8. F of 2, we take 0.5 times the previous value, which is 8, so that would be 4. So you can see we're dividing each of these by half. As these values increase, these are each being cut in half. So we'd have 2, 1, 1/2, and then 1/4. We can graph these, so 0, 16, 1, 8, 2, 4, 3, 2, 4, 1, 5 1/2, and 6 1/4. So here, we want to plug in our values. So our initial value is 1. So f of 1 would be 3 times 2 to the 1 minus 1. So that's 3 times 1, which is just 3. F of 2 is equal to 3 times 2 to the 2 minus 1. So that's the same thing as 3 times 2, which would just be 6. F of 3 is equal to 3 times 2 to the 3 minus 1. So that's the same thing as 2 squared, which is 4. 4 times 3 is 12. F of 4 is equal to 3 times 2 to the 4 minus 1. So that's 2 cubed, which is 8. 8 times 3 is 24. And then f of 5, the last one we're given here, is 3 times 2 to the 5 minus 1. So that's 2 to the 4th, which is 16. 16 times 3 is 48. So you can see each of those are getting doubled each time. We can graph these. 1, 3, 2, 6, 3, 12, and that's as good as we can do on the graph that we're given. Number 7. So we have to look and see we're given the first point, f of 1 is equal to 2. So that's our first point on our chart here. So that means f of 2 will be 3 times our previous answer, which is 2. So that would be a value of 6. F of 3 will be 3 times the previous answer. Previous answer was 6, so that would be 18. F of 4 is 3 times the previous answer, so that was 18, which ends up being 54. And then f of 5 is 3 times the previous value, 54, which would be 162. So we're getting really big values here. We're getting multiplied by 3 each time. We're not going to be able to graph much here, just those 3 points. We can do some more modeling, this time with geometric sequences. The Wimbledon Ladies Singles Championship begins with 128 players. Each match, 2 players play and only one moves to the next round. The winners compete until there's one winner. How many rounds must the winner play? So some important information. The first round requires 64 matches. Number of matches, 128 players, 128 divided by 2, 64 matches. So that means A is 64. The next round requires half as many matches. So that means R is equal to 1/2. Our values are decreasing by 1/2 each time. So let n represent the number of rounds played, and f of n represent the number of matches played at that round. So create an explicit rule and a recursive rule for the tournament. The final round will have 1 match, so substitute this value into the explicit rule and solve for n. So our explicit rule would be our initial value 64 times our rate 1/2 to the n minus 1, since we're starting at round 1. So for values of n greater than or equal to 1. Recursive rule, we take our rule 1/2 times f of n minus 1 for values n greater than or equal to 2. And our original point is that f of 1 is equal to 64 matches. So the final round will have 1 match, so we substitute into the explicit rule. 1 is equal to 64 times 1 over 2 to the n minus 1. So we divide 1 over 64. 64 ends up being 2 to the 6th. So 1 over 64 is the same thing as 1/2 to the 6th power. So since the two bases are the same, we can set the powers equal to each other. So 6 should be equal to n minus 1, n will equal 7. So that means the winner must play 7 rounds. The answer 7 rounds makes sense because using the explicit rule gives f of 7 is equal to 1. The final round will have 1 match. The result can be checked using the recursive rule, which again results in f of 7 is equal to 1. Here we've got a particular type of bacteria divides into 2 new bacteria every 20 minutes. Scientists growing the bacteria in a laboratory begins with 200 bacteria. How many bacteria are present 4 hours later? You will just have to check back in to the next video to see how many bacteria there are.